The Grisha-class anti-submarine ship is designed to search for and destroy enemy submarines found in coastal areas. Ships of the project were designed to find and destroy high-speed enemy submarines and warships escort convoys in the near-sea zone. It has a limited seagoing capability. In 1991 the Russian Navy operated over 70 Grisha-class frigates, but that number had dwindled to 28 by 2004. This was due in large part to the difficulty in replacing the ship's turbines. The first series of Grishas was built from 1968-74, but successive improvements to the design led to 4 discrete versions, 3 for the Navy and 1 subclass for the KGB coastal patrols. Classified by the Russians as small anti-submarine ships, the Grishas pack a heavy anti-submarine armament into a relatively small hull. Combined with a respectable anti-aircraft armament, this makes the Grishas much more effective than the profusion of older escort vessels that were retired in the late 1980s. The idea of creating the ship Project 1124 as a specialized high-speed anti-submarine small displacement ship occurred due to the advent of foreign submarines of the new generation and the need for effective measures to counter them in all sea areas, including and in the coastal areas near the naval bases and ships of the domestic fleet. The task for the development of small anti-submarine ship, IPC, PR. 1124 Albatross was issued in 1963 to Zelenodolsk CDB 340, which had previously developed the patrol ships, DFR, anti-submarine warfare, ASW, of the first and second generations. Preliminary design of the new ship, Chief Designer Yuri Nikolsky, watching from the Navy officer CRIVC Captain 2nd Rank Igor Kozlovsky, was considered in June 1964. The IPC technical project was completed in 1965. Technically, the project was implemented in 1965, meeting all requirements of the Navy for a well-armed at that time. It was quite a specialized vehicle for high-speed search and destroy submarines off the coast with a total displacement of 900 tons. As approved in 1972. The adjusted PR. 1124 total displacement of the IPC amounted to 940 tons, along with simplified geometry protruding hull parts. Full speed when operating the ship diesel engines and gas turbines exceeded 35 knots. The hull is steel, flush with considerable shear at the bow and broad end, which occupies the entire width of the hull. Superstructure extended 4. The ship was built in the longitudinal framing system with the size of the spacing of 500 mm and had an upper and lower deck, platform, and second bottom of the hold. Thickness of cladding in the fore and aft ends was 8 mm in the machine sections -7 mm, and in the middle part -6 mm. The second bottom has a thickness of 5 mm and a thickness of flooring decks and platform's main bulkhead reached 4 mm. The volume of the double bottom, constituting almost 90% of the length of the body, is used to store fresh water and fuel. Bow and stern superstructure, internal part of the enclosure and the foundations were made of aluminum magnesium alloys, AMG5B, to reduce displacement. The mast presented a tower-like 4-mast square section and a 3-legged mainmast of light alloys. The ships were installed with systems for year-round cooling and air conditioning in residential, office space and military posts, which allowed ships to maintain the premises in a normal temperature, humidity, cleanliness and air turnover. The ships are also equipped with space heating and ventilation systems, utility steam and system of fresh water. The steering gear is 2-cylinder electro-hydraulic steering apparatus of R14 piston driven by 2 balancing wheel. Management rudders carried autopilot Python 211 or manually from the steering gear compartment. Balancer streamlined rudder made from steel SXL 45 and weighed with a filler without rudder stock -810 pounds. The weight rudder stock of forged steel was 365 kilograms, and the angle does not exceed the rudder's, 36.5 degrees. The P159M retractable thruster propulsion and steering column is equipped with electro-hydraulic lifting, lowering, and electromechanical drives. The propeller rotation and column control system UK3K, fencing wire mesh, a 50-litre tank of the hydraulic system and the special design niche with metal bars in the stern of the ship's hull. Management of the column was carried out remotely from the wheelhouse with UK3K system or backup remote control in the steering gear compartment provided, and emergency management steering column with a manual drive to prevent freezing device provided for heating it with steam. Perform more than 12 inclusions thruster for an hour because of technical limitations are not recommended. The device was located in the steering gear compartment ship in the center line and was intended to keep the ship on foot. Contrary to the waves, anchoring device consisted of 2 anchors haul weighing 500 kilograms and 2 anchor chains 200 meter long high strength, with struts, buttresses, caliber 28 mm, chain stoppers, deck and anchor hawse, chain lockers under the platform of the forepeak, anchors and mooring capstan type electro shag 12 located in the nose, provided the anchoring at a nominal depth of 50 meters and etching anchor and anchor chain at a rate not less than 23 meters per minute. Management spire was made from the pilot house and the local post at the breakwater. The power plant has a manual 3-shaft, diesel gas turbine with 2 diesel units, DDA, M507A at 10,000 horsepower. Everyone who worked through the summing reverse gear on board 2-bladed fixed pitch propeller, PN, with a diameter of 2.0 meters and a gas turbine, GT, M8M capacity of 18,000 horsepower, which ran on the middle screw Photoshop diameter of 2.4 meters. The unit M507A weighed up to 17 tons and equipped with 2 diesel engines M504B with a capacity of 5,000 liters. Each of gear and transmission, providing a joint and separate operation of diesel engines, reverse clutch, charging system. Diesel M504B with a speed of 2000 rev per minute. Resource until the first full bulkhead diesel at 3,500 hours and a weight not exceeding 7.5 tons. Main gear, summing reversing gear, may serve until the first full bulkhead in 6,000 hours. Gas turbine power M8M 18,000 horsepower provides the full stroke, afterburner, to 35 knots. Technical capacity turbine is 10,000 hours. Turbine startup time from cold to idle no more than 3 minutes, and the development of full power possible in 10 minutes, including the preliminary stage of a 5-minute warm-up. Full marching speed of the ship under 2 DDA was 22 knots at an average freely rotating shaft. Cruising speed under 2 diesels M504B reaches 16 knots. As with most other classes consisting of large numbers of small units, the identity and status of most individual units of the Grisha class is poorly attested. The correlation between construction sequence and current status and the names and numbers of most listed units is largely conjectural. One extremely authoritative source reports a total of 88 ships of this class were built, but other sources provide other numbers, with Russian ships.info suggesting 86 plus 6 export units. Initially, the ships of the project were considered successful and construction continued until the collapse of the Soviet Union. Upon completion of construction of the IPC series PR.1124 they were a part of all 4 fleets of the USSR. As of 2007, www.armsexpo.ru reports that the Russian Navy had 5 IPC PR.1124, the rest were decommissioned in the 1990s, or transferred to the neighboring countries. IPC 44 and IPC 108, in 1993, Lithuania and renamed F-11 Zematus and F-12 Orkstatus respectively, and the IPC and IPC 5243, In 1997, Ukraine renamed U-210 Kherson and U-209 Sumy. 3 IPCPR.1124 is a part of the FAPS, and Russia are on duty for the protection of the border on the Pacific Ocean. Hope you enjoyed. Please consider subscribing.